In this example, we are having a situation that is compounded continuously, and so we're going to create an equation, and we're probably going to use logs to solve it once you see the equation. So first thing is interest is compounded continuously. So suppose that $2,000 is invested at an interest rate K, they don't give us that, compounded continuously and grows to this amount in 5 years. So the fact that they use continuously, that tells me that we are looking at a PERT type of an equation. All right, so this is your value with respect to time, so that's going to change as time changes. This is our initial value, this is our rate, and this is our time. So I'm just going to plug in some of the values that they tell us. So they suppose that $2,000 is invested. They don't tell us the rate, but they tell us that in 5 years it's going to become this, 2504.65. Okay, so what is the interest rate? So we're looking for what the rate is. So we're going to solve this. First thing is we're going to try to isolate this piece. So that means we're going to divide 2,000 over. Divide that over. I don't know what that is, but it's probably going to be some decimal that goes on, so I'm going to not divide it. I'll let the calculator deal with this at the end. So the only way to get this exponent out of here is to log both sides. So we'll log both sides, and that's going to get us 4.65 divided by 2,000, and we're going to log this. The reason we do that is so this exponent can come off of the logs, because logs don't keep exponents. So you're looking at a 5r natural log of e, and then again, I don't know, whatever this decimal is. If you do put it in a calculator, just make sure that you keep on using that value. So you can always scroll up and highlight that value and make sure it keeps on using it. Might be a little bit quicker than having to rewrite this every single time. This natural log of e is a 1, so that'll go away. And then last thing is we're going to isolate this by dividing by a 5. So our rate is going to be, we'll round it to 3 decimal places, 0, 4, 5. So we're looking at a 4.5% growth rate. If we started with $2,000 and 5 years from now we had 2,500. So we were earning 4.5% per year. All right, so then based on that, what is your exponential function? So just make sure you read directions to know what they're asking for, if they just want the decimal version of it or if they want the percentage version of it. So the equation we're going to use is, we're starting with $2,000 and our rate is 0.045 times t. So that's probably what we're going to use for any other question past this. So what will the balance be after 10 years? So in 5 years you got this, it's compounding, so it's not going to double it, it's going to be more than that, which is good. So we're going to look at P of 10. So we're going to be plugging 10 right into this equation. So we're starting at 2,000. And then we have now our rate. And that's just something we're going to plug right into the calculator. And like I said, it's going to get us more than a $500, another jump, but it's going to be bigger than $500. And if you plug that right into the calculator, you're going to get 3,136.62 roughly. All right. And then part D, how long will 2,000, after how long will the 2,000 have doubled? So that is looking at a specific value. So if we start with 2,000 and we double it, we want to know how long it takes for that to happen. So what we don't know is the time associated with that. So we're going to be solving for t. So we'll start by isolating this piece again. So it's going to look very similar to what we did here. Good news is you're doubling. So when you divide this over, you're just going to get a 2. 0.045 t. And then here again, we're going to have to try to get the exponent out of there, so we're going to log both sides. So I natural log it because I know that this is going to clean up really nice. We pull the exponent in front. So the natural log of 2 equals 0.045 t natural log of e, all multiply together. That's just a 1. And then we'll divide by 0.045. So t is going to equal about 15.4 years. Okay, and that was an example of an interest compounded continuously on a certain amount of money.